welcome you in the lecture series of Basics of Communication Engineering. It is third lecture of this series. In previous lecture, we have discussed about elements of communication system. In this lecture, I would like to discuss about evolution of communication system. The outline of this lecture are evolution of communication system, types of communication system, the goal of communication system designer. In the objective of this lecture, you will able to explain the different generations of communication system and the difference between analog and digital communication system, and also you will able to explain the goal of a communication system designer. So first of all, we will discuss about evolution of a communication system. First generation. Nippon Telegraph and Telephone (NTT) in Japan rolled it out the first generation of mobile telephone system in 1979. It is based on analog communication, that is, the voice of call is modulated to higher frequency rather than being encoded to digital signals. Analog signals degrades over time and space, and that is, there is a lack of quality within the call. The second generation 2G was started in Finland in 1991. It was based on Global System for Mobile Communication (GSM) standard. It allows for digital voice and data to be sent across the network and allowed user to roam for the first time. It also provides improved security and privacy for the telephone calls. 2G introduced many of fundamental services that we still use today, such as short message services (SMS), the call hold, and billing based on services, that is, charges based on long distance calls and real time billing. 2.5G in between year 2000 to 2003. An upgrade in the technology introduced the packet network, which provides high speed data transfer and was known as 2.5G. The standards include General Packet Radio Services (GPRS) and enhanced data rate for GSM evolution. The third generation 3G was introduced in 1998 but commercially was available in 2001. The goal were to facilitate a greater voice and data capacity and increased data transmission at lower cost. For the first time, this generation supported high-speed wideband internet access as well as fixed wireless internet services and allowed for video calls, chatting, and conference, mobile TV, video on demand services, navigational maps, email, mobile gaming, music, and digital services such as movies. Significantly greater security features were introduced in 3G, including network access, domain security, application security. It involves UMTS, Universal Mobile Telecommunication System, and Code Division Multiple Access, CDMA 2000. And 4G was fourth generation 4G was introduced in 2008, but commercially was available till 2000 in 2010 and used till date. Its purpose is to provide high speed, high quality, high capacity to user while improving security and lower the cost of voice and data services. Multimedia Internet over Internet Protocol (IP). The major benefit of an Internet Protocol IP based mobile or network is that it is able to hand over for voice and data to GSM, UMTS, and CDMA 2000 technologies from previous generations. And 4G introduced long-term evolution LTE. So 4G has introduced the LTE standards, which only supports packet switching and IP networks. Now we are about to enter in the era of 5G. Now we are about to enter the era of 5G, which is expected to be available by the start of 2021. The speed of 5G would be 1000 times of 3G and 100 times of 4G. It will control thousands of network and will give the strength the Internet of Things IoT applications. It has a speed of 4 Gbps, which means you will be able to download 50 GB file in just 1 minute, and 100 GB file will be downloaded in 4 minutes approximately. 5G is in 1 square kilometer can connect 1 million devices. It will have more features which will change our world. After 5G, XG will involves terahertz frequencies and artificial intelligence applications and Li-Fi technology, etc. Now we will discuss about types of communication system. In the design of a communication system, the information source, communication channel, and the information end user all are specified. The challenge is to design the transmitter with encode modulate the message signal generated by the source of the information, transmit it over the channel, and the and the challenge is to design the receiver with the produce an estimate of the transmitted signal at the receiver input uh, that specify the requirements of the end user. And also the challenge is to design all these with an affordable cost. There are two types of communication system: analog system and digital system, with the design requirement to satisfy the user. So first of all, we will discuss analog communication system. The design of analog communication system is simple in conceptually, but difficult to build because requirement of linearity and system adjustment. In signal processing terms, the transmitter consists of a modulator and the receiver consists of a demodulator. And we will discuss about these modulator and demodulator in the coming lectures. The simplicity of analog system is is also due to the fact that analog modulation techniques, exemplified by their wide use in radio and TV, and there is no significant effort made by the system designer to trail the waveform of the transmitted signal to suit the channel at any deeper level. Analog system performs poorly in presence of noise, and the study of analog modulation motivate other digital modulation schemes. Analog system performs poorly in presence of noise. They are being replaced slowly by the digital system. And this is the block diagram of the digital communication system. The fundamental blocks of the transmitter and receiver are source encoder, source decoder, channel encoder, channel decoder, modulator, and demodulator. The source of information is assumed to be digital. If it is analog, then it must be converted first to the digital. So first of all, here we will discuss source encoder and decoder. The source encoder converts the digital signal generated at the source output. This is message signal that is generated at the source output, and source encoder convert into another signal in digital form. Source encoding is used to reduce or eliminate redundancy for ensuring an efficient representation of the source output. The source encoder is responsible for the efficient use of the channel Different sources encoding techniques are pulse code modulation, delta modulation, adaptive delta modulation, etc. The resulting sequence of symbols at the output of the source encoder is known as code word. The source decoder is at the receiver end, behaves exactly in an inverse way to the source encoder. It delivers the source or it delivers the user or destination the original digital source output, so it will estimate the message signal at the receiving end. The main advantage of using the source coding is that it reduces the bandwidth requirement. Now, channel encoder decoder. The channel encoding is basically done to minimize the effect of channel noise. It produces a new sequence of symbols known as channel code word. The channel code word is longer than the source code word. By adding the redundancy like parity bits in source code words, which helps to detect and correct errors at the receiver side and make the system more reliable. The channel decoder at the receiving end, it map the channel encode words into the estimate source code words in such a way that the effect of channel noise reduced to minimum. And so you can see here that in source encoding the redundancy is removed, whereas in channel encoding the redundancy is introduced in a controlled manner. The source encoding alone or channel encoding alone can be performed. It is, it is possible to change the sequence in which channel encoding and source encoding are being performed. Channel and source encoding improves the system performance at the expense of increased circuit complexity. The modulator and demodulator here, modulator represents each symbol of the channel code word by corresponding analog symbols or signal. The sequence of analog symbols produced by the modulator is known as waveform, which is suitable for the transmission over the channel. The modulation techniques are amplitude shift keying, frequency shift keying, or phase shift keying. At the receiver end, the channel output, that is received signal, is given to the demodulator to produce an estimate of the channel code word. In figure, the combination of modulator, channel, and demodulator is known as discrete channel because its input as well as output are in discrete form. So at this point here, this is digital, and the input to the discrete channel is digital, and output of the discrete channel is in digital form. So this is also known as discrete channel, the combination of modulator, demodulator, and the channel. In traditional systems, the modulation and encoding are performed separately, but this increases the bandwidth requirement. So in some applications, these two operations are performed simultaneously. Now, the goal of communication system designer. The goal of communication system designer is to configure a system that transports a message signal from a source of interest across a noisy channel to a user at the other end of the channel with the objectives as the message signal is delivered to the user both efficiently and reliably, subject to certain design constraint, allowable transmit power, available channel bandwidth, and affordable cost of building system. Let B is the channel bandwidth and SNR is the signal to noise ratio. And then from the information capacity theorem, the Shannon's information capacity is C is equal to B log to 1 plus SNR bits per second, and this C is defined as the maximum rate at which information can be transmitted across the channel without error and measured in bits per second. This theorem provides a bound on what rate of the data transmission is theoretically attainable for prescribed value of channel bandwidth B and received SNR. We may use the efficiency of the communication system eta, it is equal to R by C. R is actual signaling rate bits per second and C is the channel capacity. If R less than C, then there is error free communication with this according to this theorem. Eta is the efficiency of the digital communication system and close to eta close to unity. If eta close to unity, the more efficient the system is. So this shows the maximum rate at which the reliable communication take place over the channel. This equation provide a basic for the trade-off between channel bandwidth and received SNR. Here SNR is proportional to C by B or SNR proportional to R by B. For fixed signaling rate, we may reduce the required SNR by increasing the channel bandwidth. So it gives the motivation for using a wideband modulated scheme, that is pulse code modulation, for improved noise performance. And this equation provide framework for comparing the noise performance of one modulation scheme against another. Another key issue is the efficiency with which information from a given source can be represented, that is minimum number of bits required to fully represent the source. So we have answer of two questions in this discussion. What is ultimate data compression? Means source encoding will give you the compression technique, means it will remove redundant and provide efficient representation of the source. And what is ultimate data transmission rate of the communication? That is, it will give you the channel capacity. So from the channel capacity theorem, it will give you what should be the transmission rate for error free communication. And this is the end of this lecture. Here we have mainly discussed about evolution of communication system, types of communication systems, and the goal of communication system designer. This was lecture third of the lecture series of basics of communication system. In the next lecture, I would like to discuss about analog and digital signals, time and frequency domain representation of the signal, propagation time and wavelength, transmission impairments. Till then, thanks for listening this lecture. Thank you.